According to the National Electrical Code, specifically Section 250.122, the grounding conductor size should be determined by the rating of the overcurrent protection device, such as a circuit breaker or fuse, protecting the branch circuit. Section 250.122 addresses equipment grounding conductor sizing for branch circuits. 250.122 covers situations where the branch circuit is protected by a circuit breaker or fuse rated 20 amperes or less. In this case, the equipment grounding conductor must be the same size as the branch circuit conductors. Now, 250.122b deals with branch circuits protected by overcurrent devices rated over 20 amperes. Here, the equipment grounding conductor must be sized according to Table 250.122. Table 250.122 provides minimum sizes for equipment grounding conductors based on the rating or setting of the overcurrent protective device in the circuit ahead of the equipment. To determine the appropriate grounding conductor size, firstly, identify the rating of the circuit breaker or fuse protecting the branch circuit. Secondly, refer to Table 250.122 to find the corresponding minimum size for the equipment grounding conductor. Note that the table provides minimum sizes, and you are always permitted to use a larger grounding conductor if desired or required by specific design considerations or local codes. Because the size of the branch circuit conductors was not specified, a definitive answer regarding the grounding conductor size can't be given. However, if the branch circuit conductors are larger than #6 AWG, the grounding conductor must also be larger than #6 AWG. Remember that proper grounding is crucial for electrical safety, as it provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. This helps to prevent electrical shock hazards and minimize damage to equipment. Also ensure all electrical work complies with the latest edition of the National Electrical Code and any applicable local codes and regulations. It is essential to consult the specific requirements of the local jurisdiction, as they may have amendments or additions to the NEC. When installing electrical systems, consider other factors such as voltage drop and conductor ampacity to ensure the safe and efficient operation of the system. Voltage drop refers to the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Conductor ampacity refers to the maximum current the conductor can carry continuously without exceeding its temperature rating. Select conductors with sufficient ampacity to handle the expected load current. Grounding electrode conductors connect the equipment grounding system to the grounding electrode, such as a ground rod or water pipe. The size of the grounding electrode conductor is determined by Table 250.66. Based on the size of the service entrance conductors. The equipment grounding system connects all non-current carrying metal parts of electrical equipment to the grounding electrode, providing a path for fault current to return to the source. Proper bonding ensures that all metal parts are at the same potential, minimizing the risk of electrical shock. Bonding jumpers are used to connect metal parts together, creating a continuous electrical path. The size of bonding jumpers is determined by 250.102 based on the size of the circuit conductors. In addition to sizing grounding conductors correctly, it is important to install them properly. Grounding conductors should be run with the circuit conductors in the same raceway or cable, ensuring a low impedance path for fault current. Grounding conductors should be securely connected to equipment enclosures and grounding electrodes, using approved connectors and methods. Regularly inspect electrical systems to ensure that grounding conductors are intact and properly connected. Look for signs of damage or corrosion and replace any defective components immediately. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults and interrupt the circuit, protecting people from electrical shock. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. Arc fault circuit interrupters, or SIs, are devices that detect arc faults, which are dangerous electrical conditions that can cause fires.
Size are required in many locations, such as bedrooms, to protect against the risk of fire. Surge protective devices, or SPDs, are devices that protect electrical equipment from voltage surges, which can damage sensitive electronics. SPD are recommended for all electrical systems, especially those that serve sensitive equipment. Always follow the manufacturer's instructions for installing and maintaining electrical equipment, including grounding conductors. A proper installation or maintenance can compromise the safety and performance of the system. When working on electrical systems, always energize the circuit before beginning work. Use appropriate lockout/tagout procedures to prevent accidental re-energization. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect against electrical hazards. If you are not qualified to work on electrical systems, hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Keep up to date with the latest electrical codes and regulations, as they are constantly evolving to improve safety. Attend training courses and seminars to enhance your knowledge and skills in electrical work. Share your knowledge and experience with others to promote electrical safety. By working together, we can create a safer electrical environment for everyone. Remember, grounding is not just about protecting equipment, it is about protecting people from electrical shock. Proper grounding is essential for the safe and reliable operation of electrical systems. In summary, when sizing grounding conductors for branch circuits, always refer to the National Electrical Code, specifically Section 250.122 and Table 250.122. Ensure that the grounding conductor is sized appropriately for the rating of the overcurrent protective device and the size of the branch circuit conductors. Install grounding conductors properly and maintain them regularly to ensure the safety and reliability of the electrical system. The size of the equipment grounding conductor is crucial for safety. An undersized conductor may not be able to handle the fault current, leading to a dangerous situation. An oversized conductor, while not harmful, is unnecessary and adds to the cost of the installation. The type of raceway used, whether RGC or PVC, does not affect the size of the equipment grounding conductor. The size is solely determined by the rating of the overcurrent protective device and the size of the branch circuit conductors, as outlined in NEC Table 250.122. When dealing with multiple panels fed from a main distribution panel, each subpanel requires its own equipment grounding conductor run back to the main panel. This ensures that each subpanel has a dedicated grounding path for fault current. The equipment grounding conductor should be run with the circuit conductors in the same raceway or cable. This minimizes impedance and provides a more effective path for fault current. The equipment grounding conductor should be connected to the grounding busbar in each panel. The grounding busbar is a conductive bar that provides a common connection point for all grounding conductors in the panel. The grounding busbar should be securely connected to the metal enclosure of the panel. This ensures that the enclosure is also grounded, providing an additional layer of protection. All metal enclosures, raceways, and other non-current carrying metal parts of the electrical system should be bonded together. Bonding creates a continuous electrical path, ensuring that all metal parts are at the same potential. Bonding reduces the risk of electrical shock by minimizing the voltage difference between metal parts. Bonding jumpers are used to connect metal parts together. The size of bonding jumpers is determined by 250.102 based on the size of the circuit conductors. When installing grounding and bonding systems, always follow the manufacturer's instructions and the requirements of the National Electrical Code. Proper installation is essential for the safety and reliability of the electrical system. Regularly inspect grounding and bonding systems to ensure that they are intact and properly connected. Look for signs of damage or corrosion and replace any defective components immediately. Consider using a ground resistance tester to measure the resistance of the grounding system. A low resistance indicates a good grounding connection. If the ground resistance is high, investigate the cause and take corrective action. Educate yourself and others about the importance of grounding and bonding.
Proper grounding and bonding are essential for electrical safety. By following the requirements of the National Electrical Code and best practices, you can help to protect people from electrical shock and prevent electrical fires. In addition to the NEC requirements, consider the specific requirements of the local jurisdiction. Local codes may have amendments or additions to the NEC. Consult with a qualified electrical inspector to ensure that the electrical system complies with all applicable codes and regulations. Proper grounding and bonding are essential for the safe and reliable operation of electrical systems. By following the requirements of the National Electrical Code and best practices, you can help to protect people from electrical shock and prevent electrical fires. The grounding electrode system is a critical component of the overall grounding system. The grounding electrode system provides a connection to the earth which helps to stabilize the voltage of the electrical system and provide a path for fault current to dissipate. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The grounding electrode conductor connects the equipment grounding system to the grounding electrode. The size of the grounding electrode conductor is determined by Table 250.66. Based on the size of the service entrance conductors. The grounding electrode conductor should be securely connected to the grounding electrode using approved connectors and methods. The grounding electrode system should be installed in accordance with the requirements of the National Electrical Code. Proper installation is essential for the effectiveness of the grounding system. Regularly inspect the grounding electrode system to ensure that it is intact and properly connected. Look for signs of damage or corrosion and replace any defective components immediately. Consider using a ground resistance tester to measure the resistance of the grounding electrode system. A low resistance indicates a good connection to the earth. If the ground resistance is high, investigate the cause and take corrective action. The location of the grounding electrode system is also important. The grounding electrode system should be located as close as practicable to the service entrance. This minimizes the length of the grounding electrode conductor and reduces impedance. The grounding electrode system should be protected from physical damage. Consider installing a protective enclosure around the grounding electrode system. The grounding electrode system should be accessible for inspection and maintenance. Ensure that the grounding electrode system is not covered by vegetation or other obstructions. The grounding electrode system should be installed in a location that is free from corrosive substances. Corrosive substances can damage the grounding electrode and reduce its effectiveness. In areas with high soil resistivity, it may be necessary to install multiple grounding electrodes to achieve a low ground resistance. The grounding electrodes should be spaced at least 6 feet apart. The grounding electrode system should be installed in accordance with the requirements of the National Electrical Code and any applicable local codes and regulations. Proper installation and maintenance of the grounding electrode system are essential for the safety and reliability of the electrical system.